Welcome back, guys. I've got a Ford Focus here, customer complaint about loss of power and excessive fuel consumption. So we're going to run some diagnostics and see what's causing this problem. So we've got the scanner here, got fault code P0299. The last two zeros don't actually mean anything. So P0299 is our fault code. Turbocharger, supercharger underboost. So if it's underboosting, it's loss of power. And to make up the power, he's putting his foot to the floor to try and make up the speed. Therefore, he's using extra fuel. So we're going to run some tests and see what's causing this issue. I've just come back from the road test and I can confirm, yes, there is a loss of power. The customer complaint is confirmed. There's no boost until you get to about 4,000 RPM and you really got to put your foot to the floor, hence why he's using more fuel than he'd like to. In this current climate, with the price of fuel as it is, we're going to try and see if we can fix this problem so he can be more efficient and have the power that he deserves out of his engine. So we're going to run some more tests under the bonnet and go from there. As we have a turbo fault code, we're going to start in the turbo area, start from there and work backwards. So behind this heat shield is a turbocharger. We have a vacuum actuator for the turbo. We have a hose line that goes all the way around down to electronic solenoid, vacuum solenoid, which in turn goes to the vacuum pump. So I'm going to remove this pipe. I'm going to stick a vacuum gauge on there. We'll see if this actuator rod works. And then we'll slowly work backwards, make sure there's no leaks in the pipes that's causing this issue. So we're going to create a vacuum. I'm hold this upside down so you can see it. And the rod's working. Just going to keep an eye on this gauge, make sure it holds the vacuum. There's a rubber diaphragm in here, so you want to make sure it's not split. It seems to be holding a vacuum. So we checked here, so we know this works. I'm going to plug this back in, follow the hose all the way around back to the vacuum solenoid. I'm going to run the same vacuum test from here and see if this rod pulls up. If it does, then we know that the line has no ruptures in it and we're not losing the vacuum. Vacuum pump set up again. I'm going to put it on vacuum. Activate the vacuum again. We have negative pressure and the actuator has risen. We're just going to keep an eye on that for a few seconds to make sure it doesn't drop. No, it's all good. So far we knew that the vacuum actuator is fine. We know the hoses are fine all the way up to here. So now we're going to plug this in and check through the solenoid and into this pipe. Nothing, I'm not getting anything on there. So I'm going to remove that, pull this pipe off. It's quite a skinny pipe, so I'm going to downsize my hose. I'm going to disconnect the other pipe. We're going to do a vacuum. Absolutely nothing. I tried pressure as well. Nothing. So this solenoid valve has a diaphragm in there, and there's a doorway between one side to the other side, and it's supposed to be shut. As I'm doing the test, we're not getting vacuum or pressure build up, which means that there's a problem in this solenoid valve. I have a replacement solenoid valve here from Ford. I'm just going to connect my vacuum gauge onto that. On the end, same as this one. So I create a vacuum. You have a vacuum hold on there. Pull that off, stick it back on the one on the car. Nothing. Don't worry about my gauge, it doesn't go to zero unfortunately. So, it doesn't work. So, this solenoid valve is faulty. So, why is it faulty? Well, these do pack up. But as we've started all the way from the turbo and gone back to the solenoid valve, our journey doesn't quite end there, because the next part of this journey is the vacuum pump. So this is the hose we took off from this corner. So we just need to check the vacuum pump, because if the vacuum pump's faulty, it may have caused an issue in the solenoid. The pump may be fine, but we can't stop our journey here. We have to keep going to the last part of where the vacuum started, which is at this pump. And the vacuum pump is driven by the camshaft. As it spins, it rotates the vanes inside here to create a vacuum. Now I have a vacuum gauge here, so I'm going to stick that on the end there, start the car up and see what we see. Now we saw from that video that we had a vacuum, but it wasn't a steady vacuum. We had fluctuation, which is abnormal. It should be a smooth, constant vacuum. So it would appear that we may have a fault within the vacuum pump as well. Now these vacuum pumps rely heavily on good clean oil for them to maintain their longevity. So I'm just quickly going to check the oil and see what it looks like. It's pretty black. It suggests poor maintenance. So there's one more final check that we can do. We just had the car running, as you heard. Now, in theory, if I pull this hose off, there should be vacuum still held within this hose. And there's nothing. No hiss. Absolutely nothing. So, the vacuum is being lost through this valve. We have a new vacuum pump. This vacuum solenoid comes with these hoses. Now don't be tempted to pull these hoses off and just replace the solenoid. The reason the hoses come with it is because it's been identified that the hoses also fail internally when the vacuum pump backs up. If you don't change your oil, the pump fails, the oil contaminates the vacuum solenoid, it contaminates the diaphragm, splits it, and then everything stops working. So you must change it with the hoses. So if you haven't got a vacuum gauge, don't panic. If you've got a diagnostic scanner, if you see this vacuum pump, it's got another hose that goes off round to the back of the engine. If you follow that round, it goes to the brake servo, also known as the brake booster. And at the bottom we can see there's a sensor with a grey plug on it. Now this is the booster vacuum sensor. So I'm going to plug into it and we're going to look at some live data on that. So I'm in the car now, I've got my diagnostic all set up. I'm just going to go into the data stream. I'm going to scroll down to brake booster. See, I've already selected it, brake booster pressure measurement. So we're going to OK that. Go into it. We've got slight pressure in there because we've had the car running. If I pump the brake, you can see the pressure dropping out of the servo. We'll start the car now. It might kick me out. Right, so we've got a vacuum build-up. By the way, make sure all the hoses are back on. So the hoses are back on. We've got vacuum build-up. So if I rev it up a little bit, the vacuum's going up. But it's going up very slowly. So we're in the high 70s there. So if I apply the brake 3 times, you can see it depletes quite quickly. But look how long it's taking for it to recharge. We haven't even got back to anywhere near 70 now. I'm going to rev it right up to try and get somewhere close to where we were before. Okay, I'm just going to turn the car off. And I'm going to pump 3 times or 4 times so the pedal goes hard again. And put the foot on the clutch. So if I start it up, my foot should be creeping down as the brake booster fills up with vacuum again. But it's stuck there, so if I put my left foot on there and give it some throttle, it's a bit dark, I'm sorry. Right, my foot's starting to creep down now. And that is not normal. So you can do this basic check, even now with it running, pump 3 times, that's gone rock hard. And in theory that pedal should re-energise with vacuum and creep further down with my foot applied on there, but it doesn't, so I have to rev the car up. And now it's slowly creeping down. It's a bit difficult to see, but it's a sure way of testing that there's a vacuum pump issue. All back together. I haven't pulled this yellow tab off yet to pull the clip off because we want to run our test again. So what I'm going to do now is put our vacuum gauge back on and start it up, and we'll see what the differences. So before on the gauge it was somewhere in the orange here and it was fluctuating up and down, and now we've gone all the way over to where it says overrun because we've got maximum vacuum and no fluctuation, so that's fixed. We're back in the car and the car's running now. We're just going to check the data on that brake boost like before and see what figures we're getting. So it's brake boost selected. We managed to get as high as 77ish. So we're at 94 as I apply the brake repeatedly. It recovers very quickly. So without even revving it, it's going all the way up. I'm going to clear the fault codes now. I'm going to go for a road test. We've got oil flush within the oil. You saw how black it was, and then we're going to come back and do a full service on it. Well, I've come back from the road test. Not great news. You can see the oil warning lights on. I'm not going to leave the car running for too long. So this is another one of those problems we get with these 1 litre EcoBoost engines where the oil light remains on due to lack of maintenance and using the wrong oil. These particular engines are super sensitive to the correct oil. They use a 520 grade oil, which is a Ford spec. We keep one specific barrel just for these engines. People top them up with the wrong oil, or they don't maintain them. These engines have a wet belt, which means that the cam belt and the oil pump belt run within the engine oil, and they start to deteriorate and crumble, and those bits of fibre end up blocking the oil pump strainer. So we're going to take the sump off and have a look at it. Sorry about the noise in the background, there's an active workshop. We'll inspect the oil pump and see if we need to replace it or if we can clean it out. Well, I've now had the customer over, showed him the dilemma we're in. We normally replace these oil pumps because it's so difficult to get into these holes. And when you replace these oil pumps, it's a good idea, or it's best practice, to replace this belt. But to replace that belt, you've got to take the cam belt off. To take the cam belt off, you've got to take this pulley off, the front cover off, the engine mount off, the cam cover off, the injectors off, coil pack off. It's all to do all this job. It's about 7 hours work. So what I'm going to try and do, because we've tried to find ways of cleaning these out and it's really difficult, so I'm going to see if I can slide hammer this cap off and get in there. If we can, and it does work, we may be able to save future customers some heartache financially. That was messy. That was messy. Luckily we had that piece of cardboard there. So I've got the strainer and the cover all clean now. So we're just going to put it back in and see if it cures the problem. We use a plastic hammer so we don't damage this. All clean now. Well guys, I hope you enjoyed that video. Finishing this video from home because it's a lot quieter here. You're probably asking yourself, why a Ford Focus engine is so problematic? You know, it's a 1 litre, cheap to run, cheap to maintain, cheap to service, cheap to run maybe, cheap to service, not too bad, cheap to maintain, not so much. These engines are very problematic. They have a whole variety of faults, from oil pump failure, cam belt failure. My son used to have one of these, snapped the crankshaft, vacuum pumps packing up, electronics packing up, turbos packing up. It's not the best engine out there. The way this engine comes across to us is, when they were designing it, a whole bunch of newbies came in and said, you know what, we're going to think outside the box. We're going to develop something that no one else has developed. We're going to put a cam belt inside the engine and run it with the oil. Now those of you who are mechanics out there and know a little bit about cam belts, when the cam belt's outside the engine running dry, you take that cam cover off, get a blowgun and you blow it around there, you've got rubber dust everywhere. Now that rubber dust is inside the engine. It turns into pulp with the engine oil, acts as a grinding paste, it blocks things, it causes all sorts of problems. We as mechanics can't figure out why on earth you would put a cam belt inside the engine and run it with the oil. Now, when the cam belt is meshing with the gears, what it's doing is, as the oil gets in there, it's having to move that oil out of the way. You know, if cam belts are wearing out on cam gears when they're dry, you know, the oil isn't going to help lubricate it, it just gets in the way. You know, when these two things are meshing together, they have to force the oil out. They're almost acting like an oil pump, but most oil pumps use a gear mesh to mesh this system, but they're enclosed. So once the oil is compressed, it has to go through a channel that's been made for the oil to go through. But in this case, the oil is having to be pushed out the side of the cam belt continuously. Now, most cam belts, dry cam belts, they run a water pump. Now, if the water pump fails, you get antifreeze on top of your cam belt. You know, as best practice, you change the cam belt because now the cam belt's contaminated. You know, a camshaft or crankshaft oil seal fails and the belt becomes contaminated, you change the cam belt because it's best practice, it's contaminated. You know, when oil comes into contact with rubber, it swells, it deteriorates, it falls apart. So what? Why is it in the engine? We don't understand. So as you saw, the oil pump was blocked, the vacuum pumps failed, the actuators failed. These failures that we've had, that you saw in this video, they're not the actual failures, they're subsequent failures. The actual failure in this car is the actual cam belt. The cam belt deteriorates, causes all this problem. The strainer gets blocked, little particles end up in the vacuum pump packs up, these little particles end up in turbocharger oil feeds, they pack up. It acts as a grinding paste, it deteriorates the camshaft bearings and just unfathomable why they would design such an engine. They have cooling leaks, manifold failures, injector problems, high pressure fuel pump problems. It's just not a nice engine. You know, a cam belt on a normal car takes about 3 hours to do, and this car takes 7 hours to do. It just does not make sense why they would develop such an engine. If you have one, maintain it. If you've done 100 miles in a year or 10,000 miles in a year, get it serviced. If you're going to buy engine oil for it, make sure you buy the right engine oil for it. Don't look at an oil can which says meets the requirements of. Meets the requirements of is not an approval. You want to look for an oil can that says approved, has an approval certificate that comes with that oil. We use Shell oil, all our oils are certificated. We use Castrol oil, certificated. We use Fuchs oil, certificated. You know, if you're gonna go out your way to buy Tesco oil, that's just going to meet the requirements of. There's no approval on it. If you're going to go into Halfords, make sure that the oil that you're going to buy in there has an approval certificate. Meets the requirements of does not mean it's a good enough oil to work in your car, because no one has certified that oil. The manufacturer hasn't certified it. Meets the requirements of is not the same as an approval. Anyway guys, hope you enjoyed this video. Please remember to hit the like button. There's loads of you out there watching these videos and not subscribing. Please subscribe and hit the bell notification to be notified next time I upload a video. That's the end of my rant. I'll see you soon. Take care guys.